Before we get started at looking at this next set of formulas, I want to try to explain where these formulas are coming from. So for this, we need to return to our idea of these supply and demand curves. Remember that in this situation, we're looking at these two separate curves on the same set of axes. One of these is called the demand curve, and one of these is called the supply curve. So the demand is the one that's going to go down as the price goes up, and the supply is the one that's going to go up as the price goes up, because suppliers want to be putting more supplies on the market if the market is giving them a higher price. So the intersection of these two curves is what we called the equilibrium price and the equilibrium quantity. So this equilibrium quantity is called X1, and the equilibrium price we'll call P1. And now what I want to do is sort of consider what this area means. So let's think about this in terms of these individual buyers. So let's focus for now on maybe the first unit that gets sold. So if you look at this point, let's just so that we have concrete numbers, let's say that there's one unit that would get sold at a price of $80, for example. And let's just say that the equilibrium price ends up being $40. So the fact that the demand curve goes through the point 1, 80 means that there is one person out there who would be willing to spend $80 to get their hands on this item. But notice that if this is being sold at the market price of $40, then this person actually saved a lot of money. They were willing to spend $80, but instead they only had to spend $40 to get the item. So the amount of money that they saved over what they were willing to pay would be this area. This is a 40 by 1 rectangle. So that area is telling you the amount of money that that one person saved. And then let's say you go to the next point here and say that this point's coordinates are something like, let me move this. So say that next point's coordinates are 2, 76, for example. So remember that what the demand curve is telling you is it's telling you how many items would get sold at this price. So this is saying that 2 items would get sold at $76. Now we already know that there was one person who was desperate enough to buy this for $80, but what this second point means is that there is one more person who's desperate enough to buy it at $76. So let's think about how much money that second person saved. The second person would save $36 in total because they were willing to spend $76, but they only had to spend $40. So again, the amount of money that this person saved would be given by this area, and this area would end up being 36. And you can continue this analysis as you go, so you would continue having these rectangles, and remember that what these rectangles are doing is just approximating the area under this curve. So it turns out that the area under this curve in general is the total amount of money that the consumers save altogether over price discrimination. So if you were allowed to price discriminate, in other words, if you were allowed to go to each person and ask them the max that they would be willing to spend, and they had to pay that price, then the total amount that they would spend would be the area under this demand curve, but the total amount that they actually had to spend was just the area under P1. So, in other words, the amount of money that they save is just going to be the shaded area here. So this shaded area is what's called the consumer's surplus. Now, you're not responsible for that derivation. I just want to explain to you where this formula is coming from. The consumer's surplus can be written like this. It's the integral from 0 to x1 of that demand curve minus the equilibrium price. But notice that what this is doing is it's just taking the upper curve here, which is the demand curve, and it's subtracting this lower curve here, which is y is equal to P1. So this is just an upper function minus a lower function, and we're integrating. In other words, this is just computing the shaded area. So this is an application of our area computations earlier. And again, the interpretation of this is the amount of money that all of the consumers save as a group over what they would be willing to spend at maximum. So if I could go from person to person and price discriminate, if I could go and find the dude who was willing to pay $80 and charge him $80, and then I could find the person who was willing to buy for $76 and charge them $76 and so on, then the total amount of money that they would save by buying at this market price instead would be the consumer's surplus. So as a group, they're saving this amount of money. You can do something similar whenever you consider the supply side. So, whoops. Let me redraw the picture down here. So this time, let's just consider the supply side and the market price, P1. So notice that, let's say that the point down here, so we'll use the same numbers. Let's say that 40 is the current market price, and down here on the supply curve, we go through the point 1, 10. Remember that the x coordinate here is telling you the quantity that would be supplied in this case, and the y value is the price. So what this is saying is that there is one supplier out there who would be willing to supply an item for $10. But notice that by selling at the market price, they're actually making more than what they were willing to sell it for. So this difference here, or really this area, is going to describe the amount of money that that supplier is making over what they were willing to sell it for. So the lowest price they would be willing to sell it for is 10, but by selling it on this market, they're actually making 40 rather than 10. So the suppliers are actually also, as a group, benefiting by selling at the market price. And the total amount that these suppliers are benefiting is going to again be given by this area. So this is the total amount of money that the suppliers make over what they would be willing to sell it for if they were most desperate. So if they had to sell it for the least that they were willing to sell for. So we can again use an integral to compute this area. What we'll get is the supplier's surplus. I think we'll actually call this the producer's surplus just so that we don't have two S's. There we go. So I'll say the producer's surplus is equal to this area. Now, if I wanted to compute this area using an integral, then I would use the upper curve here, which is just the constant P1, minus the lower curve, which is S of x. So this would be the integral from 0 to, remember that this intersection point is at x1, which is the equilibrium quantity. So we would integrate from 0 to x1, and we would take the upper curve, which in this case is P1, minus the lower curve down here, which is the supply curve. So this is again just an area computation. So remember that this producer's surplus is the total amount that these producers or suppliers are making over what they would be willing to sell it for. So this person would be willing to sell for $10, but they actually made 40 by selling it at the market price. So this supplier is benefiting. And similarly, this first customer or this first consumer is also benefiting because they were willing to spend a maximum of $80 and they only had to spend $40. So these consumers and producers' surpluses are the total savings that are going to the consumers and the total profits that are going to the producers over what they would be willing to spend or charge. So that's where these formulas come from. And now we'll get started on the actual